So hi guys, welcome to Entirety YouTube channel. I'm your host Yash Raj, and today you will learn how to backtest a straddle trading system. So straddle trading system is basically a system in which you either long or short a straddle at a certain time or based on certain parameters, and just simply wait for some exit time or some exit parameter, or let your stop loss hit. Okay. So we'll initially get the data. Okay, so I have the data from the year 2019 of I have the data from 2019 1st of January, okay, till 20th of October 2020. Okay, so first of all we needed this data. Okay, so now we'll start with Python. For Python, I'm using Jupyter Notebook. Okay, so let's just create a new blank notebook. Okay, so uh, just let's just import a few libraries. Import libraries. Okay, so basically these libraries helps us ease our basically what we are wanting to achieve. Okay, so a few libraries are pandas. Okay, so here pandas is basically the library, and you're calling it as PD. So basically PD is an alias you are setting for the pandas library. Okay, so in future instead of using the pandas big name, you can just use PD to call the functions inside it. Okay, and similarly import date and time, date time. Okay, import num numpy as np. Okay, import matplotlib.pyplot as plt. So this is basically the data plotting library. Okay, visualization library. This is meant for this numpy library is meant for basically manipulating the numbers, and this datetime consists of the datetime related stuff. Okay, time and all. Then we'll be requiring to access the data which is saved in our directory here. Okay, so let me show you once again. So to access the data from this directory NFO 2019-20 data, we'll have to basically get or fetch this directory into our Python code. For that, there is a library called glob. Okay, so we'll be importing from glob. Okay, so from library glob, we are importing a function called glob. Okay, and in future we'll be requiring some expiry related date issues. Okay, for which we'll take a library called dateutil.relative delta. Okay, we'll import relative delta and Thursday as th. Okay, basically th. Okay, after this what we have to do is basically we'll fetch all the files from the directory. Let's just copy this path. Okay, so like if we press on this get info, I will show, yeah, this. Okay, So if I just type globe and do this, it will fetch for me all the files inside this NFO 1920 data folder. Okay, so we'll basically save this inside a data frame. So data frame is basically kind of an Excel sheet, you can say. Okay, where all the data are stored. Okay, so I'm saving this as path, and inside path, which is now converted into data frame, we can see this. Okay, now we are getting the 0 as the column name, so we should rename this as say something like location. Okay, so now if we check, so yeah, it is renamed. So one way is this, and the other way we can do is like yeah, so columns is equals to location. Okay, so if we directly now check, so location is already there. Okay, so one way of skipping, uh, I mean for not using unnecessary lines. Okay, now what we want is the if we check location dot ILOC of 0. ILOC of 0 basically means you can fetch a zeroth, I mean the zero position row. Okay, by which from which we can see the path name. Okay, so when we'll be backtesting through all the data, what we need is to iterate over each and every date so that we can fetch each and every day's data and calculate our or do our backtest on that data. So for fetching this, we simply want to just fetch this part. Okay, so there is a feature in this what you call Python or whatever. So you can simply split from the underscore. Okay, so underscore will separate this module. Okay, so if we just separate this, what we can see is this date part is separate. Okay, so what we want is now we want the last index. To get the last index, what we can do is uh, press -1. Okay, type -1, so we'll get this last basically element. Okay, now to get the date we want to remove this dot pkl. So similarly what we'll do is split from the date part. Okay, and now we want the zeroth one, the first element. Okay, so first element means zeroth index, the second element means the first index. So here, since our index is 0, I mean the element is first, the index would be 0. So yeah, like this. Now this is only done for the one basically row. Okay, we need to apply same for all these 440 rows. That is basically the 440 data files. Okay, 440 days data, which is around 25.07 GB. Okay, so for doing that, what we can do is just a second. Okay, so what we can now do is simply uh, do this process. Okay, for all the rows. Okay, so what is the way? We can create a column in the name of data date. Okay, wherein we can simply apply the same step. Okay, so for applying the same step we can do is path of location dot apply of lambda. Okay, space x. X basically is the iterator here. Okay, So X will check for each and every row. X is one row at an instance. Okay. So we need to separate X dot basically this module, this part. Okay. This. So yeah. Now we can just apply the this one. Oh, sorry. So ILOC is not required since we are splitting each and every element. Okay, now let's check the data frame. So as we can see, the data is now the data date is now separated. Okay, so one more thing, okay, that would come to you by experience is that this data date, as what you are seeing, is basically is not in the date format. So in future, if we access this data date in form of date, it won't be there. Okay, so what we can simply do is we can apply, we can convert this data date into the date and time format. So here our format is Y, basically the year, the M month, and the date D. Okay, percent module D. So we'll just simply copy this similar format. Okay, so for that, since the year is completely written like 2019 and not 19, okay, so we need to press this capital Y, and for month it would be small m, and for date small d. Okay, see, the format is almost completely the same. Okay, hyphen means hyphen here, hyphen means hyphen. Okay, and let's just run this. Now if we check, this is now converted into the basically let's check this info. Okay, so as we can see, this the data date column is now converted into date time. Okay, earlier it was basically path dot info. Earlier it was a simple object, now it is converted into date and time object. Okay, so let's combine this into a data into a cell. Okay. One more thing, what we can do is we can sort the values. Okay. Path dot sort values of by data date, basically data score date. Okay. So as we can see, it is sorted in the ascending order. Like the first date is 1st of Jan 2019 and the last one is 20th 10 2020. So let's just do in place equals to true. So if we do in place is equals to true, we need not basically write path is equals to. We don't need to do path is equals to this if we are writing in place is equals to true. Either this should be there, okay, or this should be there, path. Okay, so yeah, let's run this path. Okay, so now one thing we can do is we can just reset the index. Okay, so 353 380 instead it should be 0123. So path dot reset index of drop, by drop what I mean is basically we are dropping the old index. Okay, drop is equals to true, comma, in place is equals to true. Okay, now let's run this. Yeah, so as we can see, the path is now done. I mean, properly arranged all the, okay. Now the next step would be, the next step, what are we going to do is, we are simply fetching the data from the directory. Okay, so let's run a, let's open a file. Okay, so let's just open a file. So what we can do is path.ilog0, okay, of location. Okay, so how do I know this? I basically remember the this one, this part. Okay, so of which column? Location. Okay, location consists of all the rows, and dot .ilog0 means the first, this one, first row. So what we can do is simply fetch the data. So data, so how to read that? pd dot read csv. Okay, oh sorry, since our data is in pickle format, okay, this is a different type of data format. So there are more, there are lot of data formats. Okay, so that can be csv, excel, feather, pickle. Okay, so right now we are having pickle data format. Okay, so let's, yeah, check. So this is the data for the date 2019-001. Okay, I mean 0101, and yeah, that's it. So let's save this as data equal to this one. Okay, now we have the data with us. Now what is the strategy that we want to implement? What is the strategy? Okay, so we are basically implementing a straddle, or basically short straddle, hmm, that we would short at 9:20 a.m. Okay, this strategy is most common and is revolving around since the year 2020. Okay, so a lot of people have used a lot of backtesting platform. Okay, so this is basically meant, this Python, basically this video is meant to make you independent of all those platforms. Okay, so a short straddle that we would short, or basically sell at 9:20, hmm, and would place a stop loss of 20% per leg, and and an exit time, or maybe target taking time, or target, or profit booking time, or loss booking time, whatever, or target taking, hmm, or PNL booking time of 3:20, 3:10, basically 3:10 p.m. Okay, so yeah, so this is the main objective of doing our backtest. Okay, so now let's start. Okay, whatever we have just written uh, here, let's just convert these into variables step by step. The first one would be the entry time. Okay, so entry time would be some date time dot combine. Okay, so this is basically to combine date and time. Okay, so are basically the entry time is date time dot time of 9 comma 20. Okay, so date time would be 9:20, but mm, we will be requiring the complete date time. Okay, since the since this Python won't take date time module won't just work on the entry time basis. Okay, so we would also be requiring the date part. Okay, so what we can do is one way is simply run a for an instance. Okay, so basically for index comma row. Okay, these index is basically iterating over the indices over the path data frame. Okay, so let's just take path data frame. So these are the indices. Okay, if I just press index path dot index. Okay, so it is showing start from 0 till stop for 440. Okay, so it will iterate over that index. Okay, and row basically means a row of that index. Okay, and in path is the data frame over which we will iterate over each row. Okay, so iter row is the function to iterate over rows. Okay, now what we can do is data is equal to pt dot read csv, or sorry, pickle. Okay, so pickle, and what we can do is row of location. Yeah, location. So location. Hmm. And let's just break basically to just get the first basically the to get to run basically this just once. Okay, so if we check data. Okay, so data is this. Okay, data has come, and the other thing is what we can do is row. Okay, so row has two components, the location and the data date, basically the zeroth index of the path 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 data frame. So what we need is data data date underscore date. Okay, so data date. Okay, so what we need here is for here to make a data date, so that would be date. So this has given us the date, okay, of that data. Okay, so suppose if we are trading today, so our date would be some 2nd of May, and time would be different. Okay, so the data date would be 2nd of May. So for that instance we are taking the data date as row of, or basically the data's date. Okay, so now the time, let's combine the time. Okay, so let's combine the time entry. Let's rename this as entry date time. Okay, so let's check the entry date time. So if if we were to back test, or if we were to trade on that day, basically 1/1/19 2019, mm, we we needed this date module and time part. Okay, time that is equal to 9:20 a.m. Okay, so yeah, so this basically entry time is that thing only. Okay, Now let's just make a similar exit date time uh, for the exit. Okay, so that would be 310. Okay, 310 p.m. So now let's check entry entry date time for that data. So for that data, 1/1/2019 is the date and 9/20 is the entry time. Okay, and for the exit date time. Okay, so date is now time is now okay. So date is now the same and time is 3:10 for exit. Okay, so now what we'll need is we need a trade log. Okay, so a trade log might be consisting of basically log a trade log for a day, or basically intraday trade log. Okay, so that would be consisting of entry date time, or just write down like this: entry entry date time. Okay, the other one would be the future traded price. Okay, so we can record the time at which the what was the basically the futures price at the time of punching the straddle, or basically shorting the straddle. Okay, so the other thing would be so the future basically traded price. Okay, so the other thing would be the ATM. Okay, what were the so this is basically in form of sequence, what all would we have done if we were trading on that day. So basically ATM and days to expiry. Okay, and what was the call symbol at that time, followed by the put symbol. Okay, then the call traded price, the call traded price. Okay, the similar for put traded price. Okay, then we would require exit date time. Okay, so what else would we require? The basically these are called entry prices. Okay, entry prices, these. Okay, now this is put entry price and exit date time, followed by the call exit price, call exit price, and the put exit price. Okay, the other thing would be the date time exit date time. See, would might be different for the call and the put. Okay, so we can basically write call exit date time and the put exit date time. Okay, and the next would be the maybe profit. Okay, so profit or loss, sorry, the PNL, and the yeah, that's it. So let's just begin now. Okay, so simply we can convert this into a data frame only, this only part. Mm, mm. What we can do is convert this into a column, data frame. Okay, so intraday trade log, intraday trade log, okay, equals to pd.data_frame of columns equal this. Hopefully no syntax error. Okay, so if we just transpose this into row format, then this is all we need. Entry date time, the future traded price, the add the money, the days to expiry, call symbol, the put symbol, call entry, call exit, call exit date time. Entry would be same for both of them. So yeah, so let's just begin by selecting the first of all the expiry. Okay, now let's just have the data over here which we want to backtest on. So uh, first of all we'll need the future traded price basically. Okay, so let's just oh, yeah intraday trade log dot p. Let's just put this in front and see the entry date time we have already defined. The future traded price is what we need. Okay, so what we can do is the based on that future traded price only we'll be basically rounding that off to the nearest 100 or base, and we would be getting the ATM. So just fetch the data, and in data what we can do is simply separate this hyphen 2, okay, or hyphen 1 or hyphen through. Basically this hyphen 2 is the second expiry. Okay, that is basically the next expiry. Okay, this 3 is the far expiry, far month expiry basically, or and hyphen I or simple hyphen 1 would be the near expiry, that is the current month. Okay, so we can separate or make a separate column in the name of the expiry type, wherein we can fetch the basically the expiry. Okay, so expiry expiry type. Okay, so the expiry type here can be three types. One, okay, current month. Okay, two, next month. Three, the next to next. Okay, so what we need to do is we need ticker. Okay, so from ticker we basically have to check if the basically the instrument type basically which is FUT. Okay, if the instrument type is equal to foot, then we would keep the ticker as this, and else we'll separate. Okay, we'll separate this module. Okay, I mean this part, and yeah, will have a column. Okay, so np.where is basically a find and replace kind of thing. Okay, So find if certain criteria is met and replace if that criteria is met. Okay, so data of okay, instrument type if equal to future. Okay, so we'll basically have the data of ticker. Okay, and we'll use apply to separate. Okay, to separate the last module. Split x dot split by, so this is hyphen, so like we did in date earlier, we'll do here same way. Okay, so this is split by this, and the last index we'll need as, so we'll get this part if we separate, I mean if we fetch -1. So further we would need to remove this dot info and yeah, dot info. Okay, so for which we will basically do this part. Okay, and else yeah, so else we'll give it blank. Okay, so let's do this. So data of, so if we can see in the expiry type column, we have now this type 2 and type 3 expiry, and if we just set this data of expiry type and set this one. Okay, so we have the 4 type of data in that column, that is, one is blank, one is first month expiry, second month expiry, third month expiry, or basically near, next, far. Okay, so now what's the next step? So the next step is basically to uh, basically the convert the string into, or basically the date, this basically the date time into the uh, basically date time format, or if it is already in that, we won't be doing that. Okay, so as we can see, this date time format is date time is already in date time format, so we won't be doing that. Okay, so for the expiry date we should also check that. Okay, so for expiry date dot I log 0, and we will check type, or basically it will automatically come in datetime dot date format. Okay, so this is already in datetime dot date format, not a string format, so it is a workable kind of thing. Okay, so the next step what we would do is basically the select the future. Okay, so in our case we need a future as, or basically the first month of future. Okay, so we take for future expiry expiry offset, or basically a future expiry, that is the current month. Okay, and the next two would be instrument. Okay, so instrument instr instrument would be nifty, suppose. Okay, and the next part would be the base at which we would like to uh, basically get our ATM. So in Banknifty we have 100 difference between the strikes, like 23,000 would be a strike, then 23,100 would be a strike, then 22,900 would be 900 would be a 22,900 would be a strike, then like these. Okay, so there is a 100 point difference between all these. So in Nifty, what is the difference is 14,000 is one strike, then 14,050 is another, then 14,100 is another, then 13,050 is another. Okay, so there is a difference of 50 points or 50 rupees basically in between the strikes. So we would take base as 50. Okay, later on we can automate this as, I mean, the code will automatically fetch the base, but for now we can simply use base as 50. Okay, so I'll later into the future codes, I would most certainly be covering those stuff as well. Okay, so now what we need is futures data. Okay, futures data. Okay, so futures data would, oh sorry, I just run this. Okay, so futures data would basically be data of instrument type. Okay, for this now remove this. Instrument type is equal to FUT. Okay, and if we just check this, we have just subset the data. Okay, now what we can do is we can add one more subset layer that can be data of instrument name equal to Nifty. Okay, that is basically, or we can directly call instrument. Okay, so we have the uh, all types of futures. As we can see, the first expiry, or basically here the expiry offset, the first, the third. Okay, so now what we can do is add one more layer of subsetting to get the current month's expiry uh, data. So for that, expiry data, expiry type, or expiry type equal to, oh sorry, this should be inside the bracket, equal to future offset, future expiry offset. So if we can see, this data is now consisting of 376 rows. That means, okay, so in a trading session, there are approximately around 375 minutes. Okay, 375 minutes. If we just calculate the time instances from 9:15 till 9 or basically 3:30. Okay, so this is basically that one. Okay, or 376, sorry. So, or maybe 377. Maybe I might be missing something. Okay. So now we have just subset the data for futures, which is having 376 rows. Now let's just reset the index. Okay, so this is ugly. Okay, let's just reset the index. Reset underscore index, or basically this is not a good practice, so we would do this later. Okay, now save the data as futures data, and in futures data we are having the mm, the 376 rows, basically that day's data. Okay, starting from 1/1/2019 till 9:15 a.m. till 1/1/2019 till 15:30 p.m. Okay, so futures data may be equal to or basically reset index of drop is equal to true and in place equal to true. Okay, so futures data is now this. Okay, properly arranged. Now the next step of ours is to basically get the ATM. Okay, so the call and the put data, but before that we need to check at 9:15 a.m. what was the ATM. So for example, the futures data at suppose 9:15, or sorry, 9:20. 9:20 is our uh, traded time. Okay, so what we can do is futures data of date time, okay, of futures data of date time equal to entry time, okay, entry date time. So this is basically the open or basically the close price of this one. So what we can do is we can fetch the uh, open price, which is 10874.3, okay. So we can get the open price, okay, which is 10874, and ILOC we need to get the zeroth index, okay. So this is that required, basically the ATM, uh, okay. So ATM, but now one problem is this is in format of 10874, which is not basically readable by the data frame, because since data frame is consisting of data as for Nifty expiries with the base of 50. So we can simply convert this ATM to round off, I mean basically in terms of basically the 50 part, okay. So base was already 50, and we can round off the ATM divided by simply the base. So if we do this, we should get 10 8 50. No, sorry. Yeah, 10 850 we should get. Yeah. So this is basically the ATM. Okay. Now we are having the ATM and we have the futures data. Now it's our turn to fetch basically the call and the put data. Okay. So for call, so call data, let's just have one. Okay. So for that, first let's subset. So data of instrument type equal to call. Okay. So yeah, we want for the Nifty instrument. So okay, and data of instrument type or instrument name is equal to instrument, okay. So we have got the Nifty, but now we are having uh, a lot of basically the expiries like 26/12, 28/12, 28/03, 2019. So for this, now we need to first basically need to calculate the nearest expiry. So nearest expiry we can calculate by nearest expiry. Okay, so for nearest expiry, uh, we need to just add or basically the uh, I mean use the date time util, or basically the related delta, okay, library to get the current the nearest Thursday expiry. So date time, or basically sorry, now we need to get the nearest expiry. Okay, so for getting the nearest expiry, what we can do is fetch the data's date expiry, okay, which is uh, today's date, or what we yeah. Okay, so we need the data's date expiry, okay. So which was, so if we were to trade on 1/1/2019, we would have taken the nearest weekly Thursday or Thursday expiry basically. So for that, what we can do is simply type relative delta, oh sorry, so plus relative delta of weekday equal to Thursday plus 1. Okay, so this is, yeah, this is the nearest expiry. Let's check this on calendar. Okay, so for year, how to do it? Yeah, so for year 2019, and the date was 1st of January 2019, the nearest Thursday was this. Okay, so this is it. Okay, so this is the nearest expiry, and so there might be cases where the nearest expiry, or basically the expiry, would have been the holiday, or the Thursday would have been the holiday. So the expiry would have shifted to a day before. Okay, so in that case, what we can do is simply add a layer of filter to this call data, or basically while fetching the data. Okay, so let's fetch the data first. Mm, and data, oh, data of expiry date equal to expiry sorry, nearest expiry. Okay, oh. So uh, this should not have occurred. Maybe this might be possible because Nifty didn't had weekly expiries. Okay, so Nifty only started trading on the, I guess, first quarter of Feb. Okay, I mean the first or the second week of Feb. Okay, so we might not be having the Nifty's data. Okay, so let's check for Bank Nifty now. Hmm. Oh, so let's check for Bank Nifty. Yeah, so we are having the data. Okay, so for the nearest expiry, okay, we are having the 6984 rows. Okay, we are having various strikes, but we want for the ATM. Okay, so what we can do is we can simply fetch the strike price, where a strike price is equals to the ATM. So strike price should be equal to ATM. Strike price equal to ATM. Oh, so is a strike price in string format, or basically data.info. So strike price is already in float format, and the ATM was, hmm, oh shit. So we need to change the base as well, since there was no base in the name of. Now we have 27,300. Okay, so let's check. Yeah, now again we are having 375 euros. Okay, that means we are now having a day's data. So there might be scenarios uh, wherein the expiry would have been a day before. Okay, so for that case, we will be adding a day, or we will be adding, subtracting basically a day or two. Okay, so okay, yes, expiry minus date time. Okay, dot time delta of days equal to 1. Okay, and same for days is equals to 2. Okay, so if expiry is before a day or two, then it would give us that data. So this is basically the call data. Okay, yeah, we now have the call data, and let's just check this. Okay, we can just simply reset the index. Okay, so let's just reset the index and drop equal to 2. So what drop does is drop just the removes that. Okay, and removes the old basically the index. If we want to drop, then it would show like this. Okay, so drop is equals to in place is equals to 2. Okay, so and similarly for put data. Okay, so call, or basically the let's just do it manually. Okay, if equal to yes, then it won't, yeah, it will bring the data. So now we have the call data. That is, first of all we have the ATM. Okay, ATM is this, our entry date time is this. Okay, the first of this, the first of Feb, and the first of Feb we are having the data for first of Feb. Okay, and the entry time date time is this. Now we have 27300 ATM, 27300 ATM, and we are having the put data as well. Okay, put data 27300 put. So we have just got the data. Okay, now we need to backtest this data. So for backtesting this data, we need basically the call, put, and futures price combined in a data frame, such that the or we can basically iterate over each and every row. Okay, so we can basically merge the call, put, and futures data side by side. Okay, with their call, I mean with their rows uh, equating to the date time of every, I mean basically instance. Okay, so let's just uh, first of let's just fetch only the required data from this data frame. Okay, so the required part would be the close. Okay, so only the close. Okay, and the same for put. Okay, and the same for futures. Okay, futures, futu, oh sorry, futures data. Oh sorry. So the futures data is this, the call is this. Now we want to merge this all together. So what we can do is pd dot concat and this. So there would be, no, there should not be this issue. Yeah, so as we can see, we are having 1126 rows. We basically don't need this. We want the data to be arranged in parallel form. Okay, one besides another. Okay, so what we'll do is we'll just place axis is equals to 1. 1 means column. Okay, so see this we are having. One thing we are missing right now is we are not having the basically the date and time. Okay, so what we can do is from here we can fetch, or basically we can fetch futures data of close, okay, alongside date and time. Okay, so now we'll reset, or basically with set index, set index index of date time. Okay, so we'll set this date time as index such that uh, our all the data would be arranged in the same manner. Okay, I mean uh, basically parallel to each other. Okay, so futures data, we are now basically uh, replacing the older futures data with this one. Okay, and we'll do similarly for call and the put data. Futures for data to call underscore data. Okay, and same for call put underscore data. Okay, so now let's remove all this, since we have the only required data with their time index as parallels, or basically index. Okay, so this is what we want. Hmm. Oh, hmm. So yeah. Hmm, hmm, hmm. Okay, so we have the data in this format. Now, one thing there is an issue is basically, let's just first in intraday. Basically, we can save this as intraday data. Okay, intraday data. Okay, so for intraday data, we are having the close as the headers, but we know that the first one is the futures data, the other one is call, and the other one is puts. Okay, so we can rename the columns, okay, as futures, futures close, the call close, or basically the put close. Okay, so the intraday, yeah, see, okay, all the data is now properly arranged in the workable format what we need. Okay, so let's just check the whole data frame. Okay, so there is a method called pd.set options. There is a method for viewing all the rows. Okay, display dot max underscore rows, and so the limitations you want to put to a data frame rows is 400 rows. Okay, and let's now run this. So we are having the complete data frame. Okay, so no data point is missing till now. So there is one missing value here at 12:46, and for put. Okay, and the other one is at the bottom for call. So what we can do is simply we can we can forward fill, FFIL. Okay, so this will basically so the 12:46, let's check the 12:46, the 12:46 Yeah. So as we can see, it just forwarded the value of the last basically index. Okay. So it copied the value from the last instance. Okay. So let's just save this. This is okay if you're having one missing value or two missing value, but if you're having a larger set of data missing, then that's an issue. Okay, that can cause an issue. Okay, so let's just save this data. Hmm. Now, what we need is basically we have the intraday data. Okay, so now we want the call and put traded price and the futures, basically the traded price. Okay, so uh, where in intraday data dot index, wherever equal to entry date time, or basically we can reset the uh, we can simply reset the index. Okay, which would bring the date time out from the index. Okay, so let's just place in place of equals. Okay, so the date instrument data of date time equal to entry date time, entry date time. So let's just get that. Yeah, so at 9:20 the future close was 27,265. The call was this and the put was this. So let's just basically mm, uh, get the let's just save this into a traded price. Okay, so call entry price is equal to traded price of call close. Okay, and the futures entry price or the future price at that instance. Okay, that could be futures close, and the put put close, put entry means put close. Okay, so we can or remove we can use open time. We should use basically open time, but now let's just use the close time. Mm, okay, 1 minute difference. So the call entry price is 100. Okay, so yeah, one thing I missed is the index should be ILOC 0. Okay, ILOC of 0. And similarly for all these. Okay, so the call entry price is 100, the put entry price is and some 225. Now we have the prices. Now the next thing would be let's just check the intraday trade law. What all is required in the trade law? Okay, so we have the call entry price. Okay, the futures traded price at that instance, the at the money, the days to expiry, or days to expiry we will calculate later. Okay, so we now need to basically save the stop loss. Okay, so the stop loss percentage we are taking here is 20%. Okay, or 20 by 100 basically. So the stop loss percentage is equals to 0.2%. So for the call and the put, okay, so let's just basically calculate the uh, stop loss for call and the put. Okay, call stop loss would be, so call, what would be the call stop loss? Call entry price plus, okay, call entry price into stop loss percentage. So that would be, since the call entry price was 100, now the 20% of which is 20, and the uh, basically the price would be 120. So let's just put this and replace this as put. So the put stop loss would be this. Okay, now, yeah, this is all done. Now uh, let's just take only the required data. Okay, so since intraday data is having basically from 9:15 till 3:30, we only want data from 9:20, okay, which is this row, and till 3:10, yeah, 3:10, which is our exit time. So we'll uh, basically place, or basically fetch intraday data, okay, of date time equal to entry time, okay, so which is this dot index, which is 5 index. Okay, so let's just 0, okay, which is 5, and the exit index 0 is out of bound. Okay, I made some mistake here. Okay, so the exit date time was 11310. Okay, now the issue intraday data, the data of 3:10, or oh, basically one mistake. So always keep in mind, if placing, always use 24 hours time format. Okay, so yeah, now we should get this. Yeah, so we now have the first index and the last index of the required data, I mean whatever we need. So I did +1 because it was whenever we just call uh, in here, basically I'll show. Okay, so this is exit underscore time underscore index is equals to this, and entry time index is this. Okay, so if we want the data from intraday data of entry time index, entry time index till exit time index, okay, we'll get uh till 3:09, okay, basically 15:09, but we want the 15:10 the data as well, so we'll do +1. Okay, so we'll now have 15:10 data as well. So okay, we have the intraday data, required data, and let's just create some required stuff. Okay, so that would be the call panel column, okay, along with the put panel column, pnl column, put panel column, and the yeah, that's it. Okay, So if we check intraday data, we'll have two zero columns. Okay. Okay. So now what we can do is simply we have already actually calculated the stop losses, and we can define we are now heading towards backtesting, actual backtesting using for loop. So we need to have a few parameters like call stop loss counter. Okay, stop loss counter such that if our stop loss is hit once, we don't need to hit our stop loss again and again. So this would basically turn the counter to 1. Okay, the call, or basically the exit time, basically call exit date time, okay, is equals to, yeah, sorry, string. Okay, so they put exit date and time, okay, with call exit price, okay, they put exit price, okay. And now let's backtest over this day, okay, over this intraday data. Okay, so one thing, reset index of draw command place is equals to 2. Hmm. So in this video, we'll only backtest over a day's data, and the another part of this video, which would be coming after a day, will be consisting of the complete data backtesting. Okay, like the data we have from the January of 2019 till October of 2020. Okay, so yeah. So now let's start the backtesting module. Okay, backtesting basically over the day. Okay, so for index comma row in intraday data dot iter rows. Okay, so we can simply set the call LTP as the row of call close, and same for put LTP, and we can just check if we can check the basically data for all these. Okay, so at here we can set the time. Okay, date time. Okay, with call LTP and put LTP. Okay, so what's the error over here? Oh, okay, so it was confused with the types of quotes. So at 21:1, okay, 9:20 a.m., the call and the put price were this. Okay, and oh, sorry, it should be like this. Yeah, now, so that call price was 100 and the put price was 225.6. Okay, so we now are having the call and the put LTPs. If we just uh, see, now what we have to do is we have to basically set the criteria for exit. Criterias for exit. Okay, so the first one, okay, so the first one here is if none of the stop losses were hit, and time limit was reached, or basically is reached. None of the stop losses were hit and time limit is reached. So in that case, the call stop loss counter should be equal to 0 and same, and put stop loss counter should also be equal to 0 with row of date time, basically the current time instance initiating the exit date time. Okay, so let's just check this outside. Okay, so this is true. Okay, so what was the date time? This is 1510, and let's check this. Yeah, both are same. Okay, so if this is the scenario, we would simply calculate basically the call PNL. Okay, is equal to just make two variables in the name of call PNL and put underscore PNL. Okay, so for call PNL, the call PNL would be equal to call entry price minus the call LTP. Okay, or basically, yeah, or the call LTP. So the entry price is basically bigger in, I mean, we are shorting in this case. So we are keeping the entry price minus LTP. Okay. Similarly for put scenario, and now we have got the call and the put PNL. We should also save the call and the put exit date time with, we need basically all these variables. Okay, so yeah. So the call stop loss counter equal to 1. Okay, and they put also stop loss counter would be turned to 1, and call exit date time would be row of date time, and the call exit price should be call LTP. Okay, so we put LTP here, and we should also save this data into the basically the data frame. Okay, the intraday data frame. Okay, so intraday data dot loc of what is the index. Okay, index is equals to index, and the call PNL, or basically the yeah, what was that name, intraday data dot t, oh sorry, cr0. Okay, so these were the uh, call and put and PNL, call put PNL and put PNL. So call PNL equal to call PNL and put PNL. Okay, so this is the scenario, and once this is done, both of our positions have exited or closed. If both of our positions are closed, we need to implement break. Okay, or basically close the trade for that day. Okay, what would be the other condition? Okay, either call or put stop loss is hit. Okay, that means none of the stop loss aren't hit till now. Okay, and currently the call or put stop loss is hit. Okay, so for this scenario, let's just code it up. If, else if, or basically elif call LTP is greater than or equal to, basically the call price, whatever the LTP has come, if it is greater than or equal to call stop loss. Okay, so the call stop loss, it would, or and call stop loss counter equal to 0 with put stop loss counter also 0. Okay, we would basically in this case update the, first of all, calculate the call and the put PNL. Okay, so the call PNL would be equal to the stop loss. Okay, so the call PNL should be equal to call entry price minus call stop loss. Okay, this is the stop loss. So entry price was 100 and the stop loss price was 120. 100 minus 120, so minus 20 would be the PNL. And the put PNL would be the put entry price. Okay, the put entry price minus put LTP. Okay, so since our call stop loss is set, we should also update the call stop loss counter to 1 so that in our next iteration this is not checked. Okay, the other thing is we should also update the call exit time and all these steps. Okay, so the call exit time equal to date row of date time, the call exit price is equals to call of LTP, and call of LTP, or basically it should be call stop loss. Okay, and the call PNL. Okay, this is okay, this is fine. So this was the scenario wherein the call stop loss is hit and none were hit till now. Okay, so we would similarly calculate for put. Okay, so this is basically elif put stop loss is hit and none were hit till now. Okay, so basically put LTP is greater than put stop loss or equal to put stop loss, and the call and the put stop loss counter were equal to 0. The call call basically PNL would be the call entry price minus call LTP, and the put PNL would be the put entry price minus the put stop loss. Okay, so the put stop loss counter equal to 0, the put exit time is equal to row of date time, the put of exit price is equal to put of stop loss. Okay, and this thing once I mean if any of these are hit. Okay, now what is the scenario, what would be the next scenario? So the next scenario could be basically the LF, or basically now hmm, either call or put SL was hit, stop loss was hit, and now other one is also hit. Okay, in such type of scenario, we would basically check first if the call stop loss counter equal to 1 and the put stop loss counter equal to 0. That means this statement basically call stop loss counter equal to 1 meaning the stop loss was hit for call and the put stop loss counter is not hit till now. Okay, but if okay, there are further two scenarios actually. If the put LTP okay is greater than the stop loss, or basically if the put LTP is greater than put stop loss, okay, stop loss, okay, then also our put stop loss is hit, but uh, but row of date time, basically the date time is before row of date time, basically the put stop loss is hit. Okay, I mean the put LTP has gone above the stop loss and or equal to the stop loss, and the date time has not reached the exit time. Okay, so row of date time is not is basically before exit date time. So in such scenarios, PNL would be equal to PE of entry price. Okay, entry price minus P stop loss, where PE stop loss counter equal to 1 and PE of exit price equal to PE of stop loss. Okay, and the call and the put PNL as this one. Okay, so this is the scenario where both of the strikes have exited. Okay, I mean the call strike and the put strikes both have exited from the trade. Okay, so we should close the shop for the day and break and come out. Okay, or what can happen is else if or elif. Okay, what can happen is row of date time is equal to exit time. Okay, this scenario can be that the stop loss was hit for call, but exit time is now reached. Okay, so in that scenario also the put PNL would be equal to this part should be copied actually. Yeah, so the put PNL would be equal to put entry price minus LTP. Okay, and the put stop loss counter, the put stop loss counter should be turned to 1, and hmm, put stop loss counter should be turned to 1 with put exit price and this part. So put exit date time should also be there. So here put exit time should be equal to row of date time. Okay, and yeah, hopefully mm, I have not skipped any part. So call PNL is calculated, put is already calculated, and yeah, so all the data is saved. Now what we have to do is simply calculate the uh, just a moment. So there can be a scenario where, but yeah, this is it. Okay, so now let's calculate for same for uh, same when the call stop loss counter was 0 and the put stop loss counter is equal to 1. Okay, so if the call stop loss wasn't hit till now and is hit now, the call stop loss price should be greater than or equal to the stop loss call stop loss, and row of date time is should be less than exit date time, that is below 310. So the call PNL would be equal to call entry price minus call stop loss, basically the stop loss amount or stop loss points. We'll later add the slippages and everything. Okay, call exit price would be the call stop loss, the call exit date time equal to row date time, and rest being the same. If call PNL equal to this and call stop loss 1. Okay, yeah, so this being done, I mean, now one thing is left. Okay, so that is basically if if none of the stop losses were hit or something like that scenario, we need to at least keep updating the uh, basically the intraday trade log. Okay, so these were the conditions. Okay, just a second. So these five are the exiting conditions. What if none of them are hit? Okay, so what to do in that scenario? Keep updating the trade log. Okay, that is intraday trade log. Let's just hit here. Update the PNL during the normal course of the day. Okay, so elif call stop loss counter equal to 0 and put of stop loss counter equal to 0 and so if call stop loss counter equals to 0 and the put stop loss counter equal to 0 and row of so one thing is uh, there can be scenarios where either of them stop loss is hit. Okay, either call stop loss is hit and or put a stop loss is hit. And the time is even not reached. So in that scenario also the PNL should be updated. So the cost of loss counter equal to 0, put stop loss counter equal to 0 or or call stop loss counter equal to 1 and put is equals to 0. Okay, and or basically mm, or call stop loss counter equal to 0 and put is equal to 1. So in that scenario just update the PNL. Okay, so this should be, yeah, or row of date time is less than exit date time. Okay, less than or equal to exit date time. Okay, in that scenario just simply update the call and the put PNL. Call PNL is equals to call entry price minus call LTP, and the put PNL equal to put entry price minus put LTP. Okay, and let's just copy from the above intraday data. Yeah, so yeah, that's it. All the entry conditions are done right now. Now let's just check the program once if this is running well. Let's just have some conditions. print conditions. I mean print statements. Okay, so none of the stop losses were hit, and yeah, first is done. So call stop loss. Hmm. Simply put stop loss for stop loss. Print. Okay, either call or the hmm, print call SL was hit, and now other one is also hit. Okay, put SL was hit, and now other one is exited based on exit time. Okay, so same for this one. Call SL. This one. Put SL was hit, and now the other one is also hit. Okay, so these were the scenarios, and now let's just run this once. Okay, so there is an error in line number 143. It's saying that unsupported operand for boolean or timestamp. Okay, so or true. Okay, so might be saying that I should remove this and I should instead use or. Yeah, or see, the put stop loss is hit and none were hit till now. Put stop loss was hit and now the other one is also hit. Okay, so let's just now save all this in the intraday trade log. Okay, so intraday trade log was having the entry date time and all these things. Okay, so let's just have the columns with us, and intraday trade log dot append intraday trade log dot append of this thing, entry date time, future traded price. Okay, the call exit price, the call date time, the put symbol, put entry price, put, and all of these things. Okay, so what we can do is simply replace this with replace. Okay, yeah, so future entry date time was the entry date time. Okay, futures futures entry prices. That time, what was the futures price? Okay, ATM is equal to ATM, and the days to expiry. Okay, so days to expiry is basically calculated by the current day. Okay, basically the uh, entry date time dot date. Okay, so entry date time dot date along with nearest expiry. So the difference between the two would be the mm, days to expiry. Okay, so days is equals to 2. Okay, simply just type dot days. So here days to expiry would be equal to this one, and call symbol. So call symbol. Okay, so one thing we need to basically set that here only. Okay, so the call data, mm, or equal, just a second, or what we can do is get the no, no, let's call symbol is equals to call data of ticker dot ILOC of 0. Okay, so and similarly for put symbol. Okay, so the call symbol is call underscore symbol, and similarly for put symbol. Okay, the call entry price would be call entry price. Similar for put entry price, the call exit price, hmm, the call put exit price, the call exit date time, the put exit date time. Okay, and what was the PNL? Okay, so one thing we can also do is we can just calculate the PNL everywhere. Okay, so just add up is equal to 0, and let's just so the PNL would be equal to call PNL plus put PNL. Okay, so the call and the put PNL, call and put PNL, and the call and the put PNL. Okay, so all are done. Now, yeah, so the let's just update the PNL as well. Okay, there is an error in entry date time. Mm, comma ignore score index equal to true. This should not come actually. Intraday trade log dot append entry date time. Oh, so what I have done here is no. Basically, the brackets should be in this is dictionary form. This should be in dictionary form. Yeah, now it should be done. Yeah. So now we have the intraday trade log data for a day. Okay. So minus 65 points. Okay. There, I'm wrapping up the today's video and will be uploading the other with the complete backtest. Okay, that would be basically 1-2 minute video, or basically let's do the complete backtest now itself only. Okay, so mm, yeah, so we'll basically be combining all this data. So what I'm doing is uh, 1 day backtest, 1 day backtest test. Okay. So for your reference purposes, I have saved this as 1 day backtest, and I will also create a copy, okay, with mm, complete backtest. Okay, complete straddle backtest. Okay, so now let's just run this. So let's just remove the unnecessary cells. Okay. This is all fine, all fine. Okay, so we have just combined all the data into one basically data frame. Okay, so now what now let's just start the back test. Okay, so for reference purposes, what I'll do is for my basically understanding, I'll print the index so that I may be aware at what file it is currently running, and I'll also use try and except so that if there is any error in the code, it just prints the basically file name. Okay, except exception as e. So this will basically print the exception with print the row of date, row of location basically. Okay, so Yeah, let's just run this. Now the complete backtest has been started and will be done till the 440 whatever number of days are there. So guys, there is a lot of thing involved in backtesting. Okay, so backtesting would involve basically separating the data into two halves, or basically three, for in sample validation and back and the out sample, or simply the in sample and out sample. Okay, so we have just done the back testing as one whole data set. Okay, we don't have the train and the test data, or basically in sample and the out sample data. So that this is basically not a good practice, but for simply learning, for initial just approach, this is a good tool. Okay, later on this channel entirety, I'll be covering a lot of stuff for you related to backtesting, execution with composite edge. It is the broker I'm using. Execution with Zerodha. Okay, and I'll try to cover as much stuff possible for the Indian along with the cryptocurrencies market. Okay, so it would be great if you guys just message the, I mean, just comment your requirement. Okay, okay. Now, as we can see, some 240 files have been done, and the time taken is around 4 to 5 minutes. Okay, as we can see, basically, so till now, as we can see, there hasn't come any exception. Okay, so there hasn't been any error. Okay, so the reason is basically I cleaned the data myself. Okay, so I'll also be sharing this data with you. Okay, through my mega link. It would be great if you guys just download this data set as soon as possible, or I'll just upload this on Google Drive. So if you guys come across any error, just try handling it using. I mean, just search it across the web. Okay, that would be the best option, because if you have come across uh, any error, the best chances are that anyone else would have encountered the same. Okay, so have the courage to just search on the Google. Okay, you would find a solution on Stack Overflow itself. So I think, yeah, so the backtest is now complete, and let's just print the intraday trade log. Oh, so one mistake I did is I should have updated the intraday trade log. These types of small issues might come. They are not very big. You can solve them by your own, by just looking at your code. Okay, so the issue is basically not that one. So the issue is basically that we have initialized the uh, intraday date, what you call. So we have basically initialized the intraday trade log inside this part, which we should have done outside. Yeah, now it is fine. Let's just restart the kernel and run. Okay, so now it will again consume my 10-20 minutes. So I would like to go with, or let's just run this full. Okay, so the time at, so it started around 5:10 a.m. Okay, now let's check. So guys, it took almost 10 minutes to backtest the complete straddle, okay, for 440 days of data. Now let's check the intraday trade log. Okay, so if we see, okay, so these are the PNLs. Let's just plot the PNLs. Okay, so dot com sum. So com sum is a basically cumulative sum. Okay, dot plot. So this is looking exaggerating at the moment. There are a lot of things to consider before taking this to your real account. Okay, I'll be covering those topics in the future coming videos. In the coming videos, I will be covering all those aspects in the upcoming videos. Thank you and have a nice day.